So welcome to Aalto University's Introduction to Research Data Management. And this training session provides an overview on the data lifecycle and gives some pointers on good data management practices, as well as provides information on the RDM support available at Aalto University. It is very much an introduction, partially because it covers the disciplinary breadth at Aalto. So this includes life sciences, technology, business, arts, and design, which of course means that the data being worked on varies greatly, as do the instruments, practices, and considerations associated with the research. So whilst this session won't go into any discipline-specific questions such as scientific computing or the details of handling personal data, we do have more advanced sessions of these things available that are open to all. So I recommend having a look at the Aalto RDM website. So though we are covering the very basics here, I hope that issues and questions we raise are ones that you can all consider from your own disciplinary contexts. How do they apply to the work that you're doing? Could they support your own research or help structure it more efficiently? As of course you are the experts within your field and know your data the best. I'll start by going through a brief outline of what we'll cover today. We'll go through what research data is, what managing it entails, why this is beneficial, what requirements funders and publishers pose on RDM, and then we'll talk through the life cycle of data in more detail and look at questions to consider at various points along the way. And lastly, we will look at some services available at Aalto to help with managing research data. So first, when thinking about research data, it can mean a myriad of different things depending on where you're coming from, your discipline. So I'd like you to consider what research data looks like in your field. What type of data do you expect to come out of your projects? It may be interview or survey data, text documents, photographs, films, drawings. It might be instrument-specific measurement data or sensor data, codes or algorithms, and software, or simulation models and production processes. So it covers a vast range of formats and different kinds of data. However, in a nutshell, the definition of research data is that it is information that has been collected, observed, generated, or created to validate research findings. So this would include data that emerges from your own research, as well as pre-existing data that you might be using in your projects, and of course, crediting accordingly. And the topic of today, research data management, refers to the organization, storage, sharing, and preservation of that research data. So research data management practices vary, of course, by field. They require, depending on how the data will be generated, what analyzing methods will be used, and also what instruments and software will be employed. And I expect RDM is something that you're all already doing, and this session is to give some pointers on how to be smart and mindful about it. And then the why of why is RDM important. Essentially, it saves you time, it leads to more efficient practices, and it essentially means taking time in the beginning of a project to decide on how you'll handle your data to avoid, spending hours scrambling around later in the project, looking for things, so wondering where that one file was, or rearranging data in a different way in order to share it. And also there are many questions, especially regarding research ethics and legal issues, that are much simpler to solve when you consider them at the planning stages of the project rather than halfway through. Importantly, good RDM practices also help you and your colleagues find and communicate about the data. So sometimes you collaborate on projects, you might get a new team member who needs to be introduced to the data. One person might leave halfway through the project and someone might need to step in to continue their work. There's that terrifying thought to consider that if someone was handed your project files right now, would they have the faintest clue what you were doing? What was the data? What were the results? What data had been already processed? And good RDM also improves transparency and the possibilities to verify and reproduce the research results. So this means that when at the end of your project, if you open your research data for other researchers, they can run your tests and verify your results. And similarly, it gives you insight into your colleagues' work in more depth than journal articles alone could provide. And this improves openness in science. And Good RDM practices enables the reuse, sharing, and opening of data. So data that is organized, named in a sensible way, and generally in order, it can be opened and shared via repositories. And you can upload your data online and have others reuse it. And what's almost even more exciting is that you have access to the data of others. So there's a whole world of interesting research data out there that you are free to use. That reuse could be taking a set of data and looking at it from another angle than the original researcher, and you can make original findings by analyzing or applying data gathered by others. And even more so these days, good RDM skills are necessary in research organizations and companies. So it's not only in research, these are becoming basic skills and requirements across industry and research institutes. And an added motivation is that funders and publishers require this increasingly. So most funders foster open data and good data management practices. And there is a general push both nationally, it's on EU level and globally towards open data. And one way of doing this is that funders require a data management plan. So researchers are now required by funders to make informed decisions about how they treat their data. It is also recommended that you open your data whenever it's possible. Of course, in some cases, you cannot open the data. For example, it might be due to trade secrets or the personal or sensitive nature of the data. However, if you can't open your data, it is recommended that you open at least the metadata. So give the descriptive information of the data, even if not the data sets themselves could be opened. Some journals, mostly in the sciences, demand data to be opened. And this is part of opening that discussion about research methodology. And the Academy of Finland and EU Horizon and EU project in general also place requirements on the data management plan. And the data management plan in this case shows to the funder that you can manage your data and be prepared to publish your data if there are no justified reasons to keep it closed. And you will meet these demands by the funders by following the Aalto Open Science and Research Policy and Aalto RDM guidelines. There's plenty of further information on this on our website. And then moving on to the life cycle of the data. So how is all this done and what does it mean in practice? This will vary by the project, depending on how the data will be generated, what analyzing methods will be used, what instruments and so forth. But more generally, it's being aware of the life cycle of the data at various stages of the research. And here you'll see an outline of that from start to finish. So we have planning, considering ethics and legal issues, organizing and documenting, storing, sharing, publishing, and then reporting and archiving. And you'll note a dashed line at the bottom. So research data can be a cycle where the data is then reused and reanalyzed. So if we start from the very beginnings of the process of planning your work. So here you might have an idea or some expectations of the material that you'll be gathering. You might be wondering about where to save your files. Is Dropbox safe for sharing files, or should you use your institutional servers? What do you need to know if you're doing interviews? You might have heard about the GDPR, and you might be wondering if you're allowed to store personal details or contact details. And you might be wondering about the best ways to organize your lab experiments. So to help you in all of this is in the data management plan, or the DMP, which is a document that describes what kind of data you will generate and how you will handle and manage it. Essentially, that's the question and answers. And as I mentioned earlier, is something that many funders require. And even if you don't have a funder requiring it, I would recommend you write that anyway, just for your project. And it should be something that should be written before you start gathering your data. And the important thing to note is that it's a plan. So it's a living document, it's reviewed and updated as you go along. And as we all know, research projects rarely go according to our best laid plans. So a DMP is not set in stone, you update it as you go on. It helps clarify some points straight from the start. And these include ownership, for example, if you're working with other institutions, and it just helps you avoid some sinkholes along the way. We recommend that you pay special attention to the legal and ethical issues if you will be using or generating personal data, if you're using data from other sources, or if you think that your work could lead to inventions or patents. So considering who do you plan on sharing your data with? Say, if you're gathering interview data and you want to share it with another university or research organization, you'll need permission for that from the interviewees. And of course, that's a lot easier to ask in the same consent form that you give them in the first place. So those kind of looking forward to be able to negate that, the effects of the sort of problems in your research. So why you should write a DMP. And it helps you be systematic about managing your data. It saves time. And if you do have a funder that requires a DMP, check their guidelines in advance and make sure that you've got the most up-to-date version of their DMP questions. So what should this DMP then answer? A few questions to get you started are, what is your data about? What's the general subject, range, or scope? How will you generate or obtain that data? How are you planning on processing or analyzing it? How will you describe it? What methods will you use? Might those be README files to give information on your data, or do you have a code book? How will you organize it? And what are the ethical and legal aspects that you should consider, and how will you take those into account? And a big part of this is, of course, how you will store and share your data. And importantly, if you are going to open your data, how will you do it? Where will you do it? When? And also, if you don't open your data, what are the reasons? And again, these are questions that are very difficult to answer at the beginning of a research project. So I would stress that this is a living document and you update it as you go along. Luckily, there are some resources to help you prepare this. So data management planning tools are available. The Finnish funders, DMP-tuuli is one of these. This is a free online tool and database for data management plans. Here you'll find some example DMPs as well. And they also have the templates that funders require, like the Finnish Academy. I personally found it really useful to just go in, snoop around and read a few DMPs made by others to get a feel for the whole thing. And there's also the Data Stewardship Wizard, or DS Wizard, which is based on a bank of short questions that you answer about your project, almost like yes, no, clicking through, and then you can export that into a template. The questions I found were very thorough, and the wizard provides links to further information, so that might be useful. There's also DMP Online by the Data Curation Center, Argos by OpenAir, and for those of you at Aalto, we offer DMP guidelines on our website. So there are guidelines, templates, and plenty of guidance available. And for those in Aalto, we also offer a review service. So if you do need to submit a DMP for a funder, you can send it to researchdata@aalto.fi for a review. We'll give you some notes on it, just help refine that plan. So that should get you started with the planning of your research. And then moving on to considering the ethics and legal issues. So when you have an idea of that data that you'll be working on, it's time to consider the ethical and legal requirements of your data. So what kind of data are you collecting? Is it personal data? Might you be collecting that? Does it need to be anonymized? When will you anonymize it and how? And a good place to start is consider if you'll be working with special data types. So these are the special data types that you should be mindful of if working with. So first is personal data. So that is data that includes information that identifies a person directly or indirectly. So this could include a name, ID number, location data, IP addresses, one or more factors that are specific to their physical, psychological, genetic, cultural, or social identity of a natural person. So keep in mind, though, that a single factor might not be used to identify an individual, but it doesn't take that many factors when provided together to identify a person. And then we have the personal sensitive data, which is data consisting of racial or ethnic origin, political opinions, religious or philosophical beliefs, trade union membership, genetic data, biometric data, data concerning health, or data concerning a person's sex life or sexual orientation. And then lastly, there's the confidential data. So this might be if you're working with a company, so trade secrets or things that might be of commercial interest. And these are the data types that you need to take into consideration to protect the rights of the research participants and also to respect the ownership of the data. So if you are working with these kind of data types, a few considerations are here. So before you start collecting, we recommend that you plan the life cycle of the personal data handling. If you will be collecting sensitive personal data at Aalto, well, you'll need to get an ethical pre-review. You might need it for other reasons as well, but the ethical pre-review is to spot any problems and help prepare for these. So to advise on when this is applicable, and you can go to the Aalto website to find if more research or more details on this if you need it. And I'll emphasize that the ethical pre-review is something that you need to do before you start gathering your data. And it just clarifies the procedures that you should do to inform research subjects about their rights and gather, so you'll need to clarify the procedures that you should use to inform research subjects about their rights and gather their consent for participating before you start collecting the data as well. And then whilst you're collecting, storing and sharing, make sure that you're using secure online data collection methods. If you're doing online surveys, for example, that you are storing and sharing services are ones that suit personal data and enable secure sharing. And a part of this is defining who has the right to your data. So if you're working with other institutions, are you allowed to share the data? Do you have consent from the participants? And then when you're publishing, obviously check that you can publish your data. Prepare your data for publishing. This might be by anonymizing the data. If you are pseudonymizing, this means that it can be tracked back to the individual, but if you're anonymizing your data fully, it means that there's no way to trace the data back to the individual. And this is actually quite difficult to do. We have a very good session on this with the Aalto RDM webinars. And if you are choosing to publish your data, define access to rights to the repository so that they suit your particular data. And again, if you can't publish it, you might publish the description of your data. So there is a lot to consider there, and this can be quite daunting, and it certainly is complex. And this is often when research need additional support from research services. And here are a few resources to help you get started. So the Aalto guidelines to meet ethical and legal requirements. So there are plenty of people at Aalto who are available to help with these if you are a student or researcher with us. So I would recommend asking your own institution of what support is available. And we also have very good open to all training on handling personal data. And we also have the research services at Aalto. We have data anonymization experts that can help with that, lawyers to help advise about the contractual things, about if you're working with companies or confidential data. And then there are a few links here to more further information. There's the Finnish Social Science Data Archive that has great guidelines available, both for DMPs and for dealing with personal sensitive data. You can have more guides about the GDPR, EU's General Data Protection Regulations, and what that is all about and how it affects how personal data can be stored and shared. And then we have links to ALIA's code of conduct for research integrity and the Finnish equivalent of that, which is THENKS, the Finnish National Board of Research Integrity. So Responsible Code of Research, which provides some ethical principles with working with human participants and the ethical review in human sciences. And often these are very case sensitive and specific to your own project. So it's worth reaching out to research services and to your own institution if you're in any doubt of how to do this and what needs to be considered. And once we've done all that planning, finally get to the actual gathering of your work. So this is when you start gathering your data. It might be measurement data, images, audio files, 3D models, whatever, calculations. And that's the point where your files start piling up and getting names like Monday test or spreadsheet updated. And that's when the need to organize that data arises. So why organize and document your data? So questions to think about when you're naming your files and putting them in folders are, will you understand your data in 5 years' time? If you're working in a research group, will the group leader understand your data? It might not even be in 5 years' time, but now. And will someone be able to pick up on the project and continue the research in the future based on your data and your documentation metadata? In some fields, peer reviewers might request to see the unopened data. And ensure that you and others can find, use, and properly cite your work or your data by naming and organizing your work wisely and describing it well. And good documentation decreases the risk of false interpretation of data as well. And of course, documenting practices are specific to the field and data that you're working with. But we'll look at a few examples of how to organize your data. So first off would be developing a logical directory and folder structure and naming your files appropriately. Here are a few examples. So it might be that the project name might have manuscripts, process data, raw data, and reports maybe. The recommendation would be to separate your ongoing and completed work and also schedule some time in your calendar when you clean the unnecessary files from the folders. We also would recommend using a consistent file naming conventions, so using just meaningful names. And if you're working in a group, deciding and agreeing on the elements which should be included. These might include the date, experiment name, the method, project identifier, version, so forth. And also make a supplementary document that describes your naming conventions and the structure of your folders and files. So if someone from outside of your project would come in, they would be able to navigate your system of filing. And there are a few places where this sort of information can be stored. So document information. So information, it can be included within data files. So variable names you might have, if you have a spreadsheet, you might have the variable names there, descriptive headers or summaries, and descriptive information, for example, at the beginning of interviews. You might be using supplementary documentation. Here we have a few links. There's the codebook guidance for social, behavioral, and economic sciences by the DD initiative. And we have the README files example there by the Aalto University, and guidance on creating a good README file. So this would be a supplementary file that you tag on to or include in your data. If you're using lab notebooks at Aalto, we have Aalto eNotebook if you do experiments. And I'd also recommend looking into the metadata standards within your field. So this is the basic bibliographic information about the data, which in data repositories or archives is used to upload the data. So they might be simple things as title, creator, and often, of course, it goes to the disciplinary specific standards. So the DDI, for example, is the Data Documentation Initiative, and that applies to the social sciences research community. But you might be working with cultural heritage or crystallographic data, for example, which have separate standards then as well. So the general standards used to describe research activity, exchanging, identifying, and just for general description of those research outputs. So look into the metadata standards of your field to ensure interoperability of your data. And just to make sure that your data includes all the necessary information and is in format that is useful to others. So what does this look like in practice? Again, varies vastly by field. I have an example for you here on interview data from a landscape architecture project on green planning. And for many, this data structure will be self-evident, but I'd like you to look at this example from the point of view, if you're giving this data set, would you know what to do with it? So what is the data? How is the data provenance explained? Is there sufficient metadata? Is this reusable? And is it accessible data in a format that's easy to use? So if you download this data file, this is what it looks like. So this is both in English and Finnish. So as a README file or 1 minute in Finnish, and then the study itself. And the information in those README files is here. It has the title, creator, affiliation, description of the data package, location. Here, they also have this suggested citation, who to contact if there are any questions, location, dates, subjects, and formats. And then if you go into the study, you also have supplementary files. And the information in these supplementary files tells where this interview data was collected from, which area, the sample, date of collection, who was collecting it, what was the method, the tools, and any kind of observations and the material. And in that appendix, there's also the questions that were asked. One thing that you might also add here is the consent forms for your participants, or the information that they received before agreeing to the project. And it's only then that we get into the data files themselves. So here are the actual interview files that have been transcribed. And you'll note that this, of course, in terms of accessibility, it is a lot easier that the interviews are provided not as audio files, but as text files. So you can search for keywords, for example. And here, this bit is unfortunately only finished, but the details of the data is also, so this is opening one of those individual data files, and it gives you the time or the date, and some information about who was interviewed, where it was done, how long it lasted, and then the actual transcribed data. So there's a lot of supplementary information there to explain the data provenance, so where that data came from, and to help others reuse it. Right. So once you've got your files then gathered and organized, we mentioned the storing of the data. This, of course, is a very big part of this research data management. And essentially, you will need somewhere that is safe and that has enough space. Things to consider about this is if your data is being backed up, it should. Who has access to your data if you're working in a group? Is your data stored safely and securely? And is it a safe and secure way to share your data if you need to do that? And these questions of safety and access become even more important when you're working on, if you might be working with private or sensitive data. And we also have a link here to Aalto ID document, which outlines the security levels and storage facilities and options available. The next session, or the next set of information, I'm afraid, is very Aalto University heavy. So I'd recommend looking into your institute's IT solutions for storage. But for those Aalto people, I asked you in a nutshell, the Aalto network drive is recommended for storage, is fast, secure, and it's backed up. And it's the best place to save your work or your data in Aalto. It's like folders on your computer, but they're more secure. You will need an Aalto account, and as always, working remotely, remote access via VPN is recommended. And if you do need to get a folder for your research group or just get more space, you can contact Service Desk at Aalto. And this is suitable for personal and confidential data. And there you'll see the personal storage space if you're working in departmental storage space, or if you're working in research groups, you'll be able to share that within Aalto. The Aalto cloud services that we have available, Microsoft Teams for collaboration, for web meetings, file sharing, and that. And cloud storage options are Microsoft OneDrive, Google Drive, Dropbox. We recommend using your Aalto account to log into those because you get more space and more features. And these allow easy sharing of non-confidential data. If you do need to save or share confidential data, it would need to be encrypted on these. And then e-duuni, which is suitable for confidential and personal data. And this is an e-work and collaboration service environment. For example, if you're working on interview data containing personal sensitive information or confidential data obtained from companies, it cannot be stored and shared via cloud services unless it's encrypted. The solution in that case could be all the network drives. However, experimental data from the lab can be stored and shared via the cloud services. And the Aalto IT services are on hand to help with these questions on figuring out which exact solution is is the right one for you. And then we get to publishing. So once you've gathered your data, organized it in a sensible way, named it logically, it might be ready to publish in a data repository. So open data is stored and published in a data repository or archive. And data in these repositories, they are available for anyone to find and reuse. And you, as the owner of the data, you decide how open you want your data to be. Will you want it to be open to all? Would you want it to be embargoed, for example, or open by request? And as the owner of the data, you also decide what license to use. We and many funders also recommend a CC license. CC BY, for example, is recommended for publicly funded research data that is open in a data repository and compliant by the Open Data Directive. This, however, does not concern software. Check your funder requirements regarding that licensing so you get it right. And again, if working with personal, sensitive, or confidential data, consider carefully what can be opened. As the Aalto Open Science Policy recommends, data should be as open as possible, but closed as necessary. And then the question of why you should consider opening or publishing your data is that published data can be reused easily by others. Only published data is an independent research output, like a scientific article is. So much like an article, they receive their own DOI number when published. And when you consider the published data as a research output, it makes sense to curate it. So your published research data set, it should be clear, well organized, and a coherent whole that validates your results. It has everything needed to replicate the study, and that is useful for other researchers. So that could include measurement data, both raw, processed data, interview data, if it is anonymized, and you might include software, for example, or your research protocols. And once you've published your data set and it has its DOI, it can then be cited by others, giving credit to you and the other contributors. And there's a definite citation advantage. So your article gets more citations if you link open data to it. And if you are publishing in a journal that has a data availability statement, you can add that information of the data there to link it to the repository. And typically, again, funders also require open data, and some journals as well. So where can you do this then? A few general repositories that we recommend for opening your data. We have Zenodo, which is EU-funded long-term repository for any data. There's also an Aalto video guide for uploading data here. And then there's the EUDAT services, which is European. There's an Aalto guide for this. And then the National Fair Data Services in Finland to store, describe, and publish data, and a guide for using those again. Or you might choose to go with a domain-specific repository that are planned for a specific type of data. This might be the repository or Cambridge repository for crystallographic data, or the FSD, so the Finnish Social Science Data Archive, which was actually where the example that I showed you of the interview data came. And in case you're wondering, there's a catalog of repositories where you can go and click through your field and see which options might be field specific to you, or then if you want to go with a generalist repository. And here are some examples of published Aalto datasets from the different schools. A lot of them are in Zenodo, as you see, and you will receive all of these slides at the end. So you'll be able to click through those links. And finally, this is again, sort of perhaps more Aalto geared, but we recommend reporting your data in your institutional repository. Organize is the Aalto Current Research Information System, but your institutions probably have similar systems set up. And in the case of Aalto, we ask researchers to send a link to the published data, for example, the Zenodo link that you might have then to research data at aalto.fi, and the information about your data will be added to Organize, and then you'll be able to link it to your article there as well. If There might be special cases where only the descriptive metadata is available for personal confidential data. It can also be published, but then it will be only that metadata. And this is a requirement from the Academy of Finland funded project. And why to do this? It ensures that your data can be identified, like your articles. It maximizes the visibility of your data, and you can easily include the data in your CV. And once the data is linked to the related articles in Acris, it's available for other research outputs as well. And last but not least, the question of archiving your data for long-term storage. And in most cases, it is sufficient that you upload your data to Zenodo, for example, that it will stay there for years. And then you might want to keep your own data files on your computer or on your network drive for a fixed amount of years, and then decide that you'll then clear them out, say, after 5 or 10 years. And that's entirely sufficient. But archiving is something, if you think the research they've done would be very valuable for long-term. And long-term here means decades or centuries. So this need to archive concerns the most significant and valuable research data. And then this data will be archived for a very long period. And the selection should follow the guidelines and criteria of scientific and or historical value and uniqueness. The Finnish national service that provides this sort of long-term preservation is provided by the CSC, so that's the Fair Data Pass service. It includes also digital preservation and updating those files over time. If you think that might be applicable to your research, I recommend just going through to the BAS site and looking up the requirements. And then lastly, bit of further training that we have available with all the RDM and the research services. Here are themes of the upcoming trainings this spring. So we have data management plans, handling personal data, sharing research data through a repository, licensing open software, help with working with restricted data sets, data anonymization, and the legal aspects, storage, and guidance on making your code or research reproducible. And then we also have a session on academic publishing. So you'll find further information on these on our website and more guidelines and materials there as well. And for those of you at Aalto, we have also more personalized help available through the data agents. So these are researchers who advise on research data management at your schools. So they raise awareness on RDM, help you figure out where to store your data, advise where to publish, help you figure out which data repository might be best in your field. And in general, they promote open data and research. And they also help devise data management plans. And we also have a Zoom sort of office hour, which is especially geared towards scientific computing on Wednesdays between 1 and 2 p.m. And as mentioned before, we have the research data at Aalto email address that you can send your questions to. And there we have the data agents, IT experts, legal counsels, and other experts to help you out. So many thanks. And I think now we will move to the end of our session.